Welcome. Today we will learn how to plot ILD for bottom card member of the truss. Okay, right. So previous session you might have listened to my lecture, the previous video, which was done on top card member. In the very similar manner, we will proceed how to plot ILD for bottom card member also. Okay. So by definition, ILD means influence line diagram, nothing but when one unit load travels across the span, how the quantity that you are interested in, whether it is shear force or bending moment or member force, in this case of truss, how it is going to change. If you plot that, that is going to be ILD for you, right? So the same manner, let this one unit load cross this span, whether it is through type or no deck type, whatever it is. Okay. So when one unit load is crossing this span, how the force in one of the bottom card members. So let me choose here the L1, L2. This is the chosen member which I am interested in. So L1, L2 member. Okay. The member force in this one, how it is going to change when one unit load cross the girder like this. Okay. So for that, as you know, method of sections we apply. So I take a section X, X. Okay. So this is the section which will cut the truss into two parts, the right part and the left part. So I have separated the two parts after cut. So this is the right part of the truss and left part of the truss. So when one unit load travels, and if it is in the left part of the truss, okay, so let unit load is on left part of truss. Okay, so when unit load is on left part of the truss, we consider the right part of the truss for analysis. Okay, because we have less number of loads, in fact only one load here, that is the reaction, let us say RB. Okay, so I consider the right part of the truss. So the load is on left part, consider the right part of the truss. So on right part, what are the forces acting on the right part? Let us see. So I draw the forces. So this member is cut here. So I expect the axial load in that member, that is noted as F U2 U3. Then this member is cut. So we expect a force F U2 L2. And this member is cut here. So you expect a force which is F L1 L2 L1 L2. So now our interest is to find F L1 L2. Okay, so by method of sections, now this I mentioned the reaction here, which is RB. Okay, right. So now this is the free body diagram of the right part of the truss, where 1, 2, 3, 4 forces are acting. Okay, now I want only this force, right? I don't want these two forces. So what you do, we use moment equilibrium equation, okay, to get the force L1 L2. Okay, so where do you consider the moments? When these two members are joining at this point, U2 joint. So if you take moments from this point, the force in this member, that is Fu to U3, and this member, no moment will be 0. You will have only one force in the equation, right? So that I'll write it. So writing sigma m u2 is 0, where I assume clockwise moments as positive. Okay, so now taking moments about this point, I mean the joining point of these two, let us say. So this point is u2. Okay, right. So these two moments are zeros. So f L1 L2 multiplied by the perpendicular distance between the force and moment center is h, height of the truss. Okay, so this is the moment value and this is clockwise, so I take it as positive, right? And the only other force remaining is the reaction here, RB, and the distance between this point and RB, let us say this is A, each panel span is A, so 1 2 3 4 5A, and that is anti-clockwise moment, so I get minus sign RB into 5 times A, right? So these are the moments acting on the right part. Okay, see, when unit load is traveling on the left part of the section, I choose the right part of the truss for equilibrium. Okay, so now by solving this, we get F L1 L2 is equal to this RB into 5A divided by H. So I am going to write this as moment about U2 point or joint, okay, whichever you call. So this has got positive sign, which means the direction that you assumed here is correct, which means tension. So all bottom cards, are in tension. Okay. So very fundamental knowledge that you already learned, that all bottom card members will be in tension. So the away from the joint here, the away from the cut surface, the force which represents tension here. So you got tensile force, and that force in the member when one unit load is traveling from U1 till the section, the force in this member is nothing but moment about U2 divided by H, right? Right. Next, if the load is on the right part, let us say the load traveling on the right part from the section till this U7. So we choose the left part of the truss. Okay. So load on right part. Okay. So now choose left part of truss. Okay. For equilibrium. Right. Because you have only less number of loads when you choose the left part of the truss. Okay. So let me draw the forces acting on the left part of the truss. So there is a member which you cut here. So there is a force developed here, F U2 U3. The member is cut here. So force in the member is represented like this. Similarly, the member is cut here. So we expect a force like this. So it's called F U2 L2. U2 L2. And the other member which is cut here is the bottom card member, and that is F L1 L2, right? Three forces because three members are being cut, and you have a reaction here which is RA, let us say. Okay, right? For the given load, RA and RB you can easily find out from the free body diagram of the truss, so which you have learned in analysis of trusses, right? Right. So now I have 1, 2, 3, 4 forces acting on this left part. Now I need only one force, this one. Okay. I don't want the other two unknowns. Okay. So let me write the equilibrium equation again. So if you don't want these two forces, so if you go for taking moments about this point, now these two forces are passing through this point, so you don't get any moment. So I choose moment equation to apply. Again, the same joint u2 is equal to 0. Same, choose clockwise as positive. Okay, so taking f L1 L2 multiplied by the perpendicular distance again is h, height of the truss. Now here it is anti-clockwise, so I get minus sign. Here it is clockwise, RA into the distance is A between the force, perpendicular distance between the force and the moment center is A. And this is clockwise, so I get plus sign, which is equal to 0, right? So for solving L1, L2, we get RA into small a divided by h. The numerator is nothing but moment about u2 again, okay, divided by h. Now you see whether the force is on left part of the truss or the right part of the truss. For all positions of the load, the force in L1, L2 is proportional to moment about u2, the joint u2. Okay, and if you want exactly the force value, it is moment divided by the height of the truss. So nothing but when one unit load is moving from u1 to u7, if you can plot ILD for bending moment about u2 and divide it by h, that is your ILD for bottom chord member L1, L2. Okay, that will do it here. Okay, so when one unit load is traveling on this truss, okay, so if you want to plot the ILD for L1, L2, okay, so let us drop these points. Plot ILD for bending moment about this joint. Okay, the other two members where they are joining in that particular panel is u2. So drop that u2 down. So let this will be a reference line. So I need bending moment ILD for this u2. Okay, so just join these. Let us this. So by joining this point here and join this point with the other end, that is 0. So 0 here, 0 here, and here if you say this is x, this remaining distance L minus x. Okay, so this ordinate here will be x into L minus x divided by x divided by L. So this is the ILD for bending moment. So if you divide it by h, now this will become the ordinate value for the ILD. So just once you divide that bending moment ILD divided by h, now you will get ILD for force in L1, L2. Okay, so this will become ILD for force in L1, L2. Similarly, for all other bottom chord members, you can plot the ILDs. You see, if you want the ILD for L0, L1, okay, so the other two members are meeting at U1. So this is your moment center. Okay, so you need to plot ILD for bending moment for this point. Okay, similarly, if you want for L2, L3, the other two members are meeting at U3. Okay, so the ILD for bending moment now will become, I'll write So taking the different color here. So if you want to plot this one, right? So this is your ILD for bending moment for this point. Join this with the other end. So this is now the ILD for member L to L3. Force in member L to L3. Similarly, L3, L4 will follow the ILD of L to L3, the mirror image of that. Okay. So similarly, L4, L5 and L5, L6. So likewise, for any of the bottom chord members, you can plot ILD for bending moment. You see, this is the tensile force. All the bottom chord members are in tension. Okay. So how do you read this ILD? See, for example, so if you are worried about the member force L to L3, so this member force, as one unit load start traveling from here, let us say, so when the load is at this point, at this joint, either U1 or L0, the force in this member is 0. Okay. When this travels like this, when it is exactly over this location, the member force is maximum. Okay, force in this member is maximum. So as this travels towards this joint, the force in this member is going to increase. Okay, and when this leaves this joint, the unit load, one unit load leaves this joint, then the force in this member is going to decrease. Okay, then once it reach this joint, U7 or L6, then the force in this member is going to be 0. Okay, so when unit load is at L0 position and L6 position, this member force is 0. And when exactly it is at this joint, okay, along this joint, then the member force is maximum. For all other positions, it is lesser value. And when load is approaching the joint here, okay, then load will increase, or the force in this member will increase. When it is leaving this joint or going away from this joint, then the force in this member is going to decrease. Okay, so this gives you complete idea about how you read ILD, right? Thank you.